motors, they were not polar. So you can connect the motor in any position. There's no negative and positive. You can connect it anyway and it works. And so this is an example of, you don't want 9-year-olds to think about what's negative, what's positive, why is it not working, I'm connecting. So they decided to put that in the design. So the design hides a lot of the electronics behind from the kids. So this was a conscious, explicit decision. Then, this same team, they created the Cricket that, some of you might know. And again, the same idea, the connectors, they are asymmetric, so you can't connect the motors in any way. There is a certain way that they go in. So again, a lot of hiding and backgrounding of different aspects of the design. The sensors are, they have a cable, you just plug them in and they work. You don't have to use resistors, you don't have to solder and all of that. And all of that was, of course, incorporated into the Mindstorms kit. And here you can see other examples of selective exposure. For example, the motors, they are geared inside. They have lots of gears. They are very easy to use, but you don't really see that they're geared. They're just motors. You plug them and they work. So another design element that the designers introduced to make things easier. This is another platform on that same lineage called the Gogo board. And again, here we, I was also part of this design. And what we decided to include here was for kids to be able to use broken and found electronics, recycled electronics with this board. So a lot of the circuitry here makes it easy for you to connect like a motor from a tape recorder or all of that, instead of you having to do all kinds of complicated things. And there's also many other platforms like the MIT Tower, and then the Lego NXT, and here you can see a lot of other kind of complexity that got hidden and backgrounded in favor of just facilitating the construction, and the Pico Cricket that you might also know. And again, when I went back and looked at the motivations for those designs, I found something, very interesting things. For example, this is from Randy Sargent's thesis in 1989, which designed the first Lego brick. And he was saying, the Lego company solves the problem of powering active sensors by sending power to the sensor over the 2 wires and then periodically shutting power off and listening for a signal back. So, they went like great distances to actually make these connectors non-polar and easy to use. And because they didn't want to expose kids to a lot of complexity of the electronics. Yes. Okay, but then now I won't know how much time I have. Fine. I'll talk as much as I want.